And good day, pre-algebra. We are starting Unit 2 with a new objective and a new battery in my mic. I think I was getting some bad reception the last couple lessons here. But here we are, PO7, comparing and ordering rational numbers. And when we talk about compare, right, the word compare means to kind of take a look at the value and say, is this better, is this worse, what's similar, what's dissimilar, right? And so we're going to be looking at not necessarily values that are equal, but we're going to be looking at values that we can order. Okay, we can order from least to greatest. Least meaning the smallest value first, greatest meaning the largest value last. And so because we're doing that, we bring in these symbols here, which you've seen before. What does this symbol mean? These would be our comparison symbols, right? Things can be equal. You know, we've talked about this before, and you've used it a lot, right? When you compare things, they can be equal, but oftentimes they aren't. And so what does that first symbol mean? Less than, good. Which means the other one is greater than. And you've probably heard a lot of different analogies over the years to help you remember these things. What's worked for you to know the difference between less than and greater than? What's worked for you? Maybe you've heard of the alligator method, right? It eats the larger number. It points to the smaller number. That's sometimes used. If you can imagine a 12, 13-year-old Mr. Schultz sitting in your desk, gazing up at, well, a chalkboard, learning math. What I used was I thought of this less than symbol as like a little squashed L, right? You take an L and you kind of squish it together and you kind of get that symbol there. So that's how I knew that that was the less than symbol. And of course, if this was less than, the other one would have to be greater than by process of elimination. Okay. So whatever works for you, cool. But have something. So you're not just constantly guessing, you know, because maybe you'll guess right, maybe sometimes you guess wrong. I got you. There you go. Okay. So we're going to be looking at ordering three types of values: integers, fractions, and decimals. Okay. And I kind of give you the little synopsis of each of these here. This is a key point, so it can go on a help sheet. First of all, you want to convert your values to the same form, right? If you're given one decimal and one fraction, it can be difficult to compare those. Convert them both to fractions or convert them both to decimals. That's why we did that in Unit 1, right? We converted back in 4. So that can be helpful, okay? For integers, you want to use a number line, right? We're familiar with that, okay? What can you tell me about values on a number line? Like which direction is greater than, which direction is less than? Adrian?
Left is less than, and right is greater.
Yeah, so anytime you've got two values on a number line, say -12 and -7, okay, because -7 is further to the right on the number line than -12, you know it's going to be greater. Okay, it's going to be the greater value. All right, so number lines can help with integers. Fractions, one method. You can compare your values to 0, 1/2, or 1. Okay. For example, how can someone defend that 7/12 is greater than 4/11? Looking at those values and comparing them to 0, 1/2, or 1. Because I don't know what the exact value of 7/12 is. I don't know what the exact value of 4/11 is. But how do I know that 7/12 is greater? Any thoughts?
Because it's further away from 1/2 than 4/11.
What do you mean further away from 1/2?
Like if you were doing the number, the graph, the number line, it would be further to the right than the 4/11.
Okay. Good thought. Any others? Tristan?
Well, if you made it one of those little circle graphs and you did 1/2, it would just be one line and two sections. But for 7/12, it would be a lot of sections.
It would be. Yeah. Another good thought. Anybody else? Okay. Well, when we compare to 1/2, is 7/12 equal to 1/2? No. And how do you know that? What is half of 12? 6, right? So 6/12 is equal to 1/2. We've got 7/12. So do we have more or less than 1/2? More. On Peyton's number line, 7/12 will be to the right of 6/12 because it's more than 1/2. On Tristan's circle chart, we'll have more than half of it filled in because 6 out of 12 is equal to 1/2, but we've got 7 out of 12. If you get 6 out of 12 on a test, what's your percentage? 50%. You got half the questions right. If you get 7 out of 12, still not great, right? But you got more than a half. Okay? How about 4/11ths? Is that equal to 1/2?
Nope.
No. What's half of 11? Well, there is a half of 11. It's not an integer, but what is half of 11? 5.5. Okay? So 5.5 is equal to 1/2. 5.5 over 11. What do we have? We've got 4 over 11. So do we have a half? No, we have less than half, right? So even though I don't know exactly what 7/12 is or what 4/11 is, I know that 7/12 is more than 1/2. I know that 4/11 is less than 1/2. Therefore, 7/12 has to be more than 4/11. Okay? That was a long explanation to get to the end result there, but the more that you practice that type of thinking, the easier it gets. The more you can say, oh, half 12 is 6, I've got 7. Half 11, 5.5, I've got 4. 7/12 is more. Okay? Get there. Also, with fractions, you can use equivalent fractions to get common denominators. That's probably the way that you were first taught growing up, right? Get those common denominators and then compare the numerators. And then decimals, I'm going to show you something called the stacking method, which the Gambino probably showed you last year, but just to kind of review that, okay? What you want to watch out for, though, I get this repeatedly. It's a pet peeve of mine. You cannot just look at how far away the denominator is from the numerator. I get that a lot. That kids will say, this is more than this. And they say, well, because, this is further away. If you look at the fractions 2/5 and 37/40, they're the same number away, right? 2 is 3 away from 5. 37 is 3 away from 40. Does that mean that they're equal? Not at all. Not at all. 2 out of 5 on a test, that's going in the bottom of the locker. Hopefully never be seen again, right? 37 to 40, hey, that's going on the fridge at home. Okay? So you cannot just look at how far away the numerator is from the denominator. It is not a reliable method to compare fraction values. Okay? If anyone told you it was, liar, liar, pants on fire. Right? Do not listen to that person ever again. No. Okay. All right, let's start with integers. Looking at -7 and -10, it says compare using less than, greater than, or equal to. Just who would like to share? Raise your hand. What symbol should go between -7 and -10? Is it -7 greater than, less than, or equal to -10? Adrian. It is greater than. Okay. If you think about that on a number line and where those numbers are, -10. -7 is closer to 0. It's further to the right. Therefore, it's going to be greater than -10. Right? -4 and +2 is what? Okay, so what symbol goes in between them? Less than. The order that they're written, right? -4 have to be less than 2. If it was switched, if 2 was first, then it would be the greater than symbol. But -4 is less than +2. This one, just look at the signs, right? Anything negative will always be less than anything positive. -2 and -9. Peyton. -2 is greater than -9. Okay, for the same reason we talked about this number line over here. Think about where those values are. -2 is further to the right. Okay, therefore it's going to be greater. Last one, -14, blank, -12. Let's get someone we have not heard from yet today. A new contributor. Gregory? What symbol should go in between here? Less than. Very good. -14 is less than -12. Right? On a number line, -14 is further to the left. Okay? The rest of these will be homework for you. You've got 4 to do in the next row, and then ordering several integers from least to greatest. Again, a number line can be helpful here. Or you know that all your negative numbers will come first, right? Because they're going to be the smallest. And then you can put your positive number second. Okay? Not a lot of time spent on integers because there's more fun with decimals. Oh, whoops. Is this messed up on your page too? Is the happy pencil?
Yeah.
Oh, that's disappointing. I have to fire my editor again.
Is he supposed to be there?
No, it's supposed to be on the next line. Because, yeah, okay, that's fine. I'll need a new editor. That's okay. We'll save this. That'll be good. Where's my save button? There it is. Okay. Decimals. Again, compare using less than, greater than, or equal to. I talked about the stacking method earlier. Who can remind me what the stacking method is? Zoe. Yeah. You kind of stack them up. And what's the value of stacking the decimals? Why would we do it? This one might not be as necessary to do it, but what's the value in doing that? What are we looking for now to compare the value of these decimals, right?
Oh, I just.
Oh, great. Well, since they're both out to 3 places after the decimal point, they're both out to the thousandths place, you can look and compare 223 compared to 793. You can do that only because they're out of the same number of places. Otherwise, you look at the whole place, and they both have 0 holes. So we move on. You look at the tenths place, and it doesn't matter what comes after that. If they've got different tenths, you can make your decision which one's greater and which one's less than. Okay? Because 2 tenths is less than 7 tenths. The whole decimal is going to be less than, in this case, 0.793. Right? So you kind of start at the left. You compare place values all the way down until you get something that's different, and then you can make your call. 67.4 and 63.22. Our tens digit is the same for each of them here. So we look at the ones digit. We've got a 7 compared to a 3. What symbol goes in the blank? Everybody at once. Everybody at once. Greater than, right? 67.4 is greater than 63.22. If you're not sure why I'm saying that, well, again, looking at that stacking method, we have the same number of tens, so we move on. We get to our ones, and one's got 7, the other one has 3. Doesn't matter what comes after that. 7 ones will be greater than 3 ones when your tens are the same. Okay? 2.54 and 2.5400. Josie, they're equal. This is the greatest thing about decimals, that you can add zeros to the end forever and not change the value. Okay? So when we stack these up and we're comparing them, well, first we want to make them out the same number of places because our ones are the same, our tenths are the same, our hundredths are the same. This one's got 0 thousandths, and really so does that one because there's no number written there. So it's the same all the way out. Therefore, they are equal. Okay? Here's where the stacking method really comes in handy, because a common mistake that folks will make here is they'll look at the 27 and they'll look at the 3 and they'll say, oh, 27 is greater than 3, so 0.27 is greater than 0.3. Is that true? No. It's not true, right? Because the stacking method, the other thing we can do is add zeros until the decimals are out of the same number of places. And now we're not comparing 27 and 3. We're looking at 27 and 30, right? 27 hundredths and 30 hundredths. Think about this in terms of money. What is more, 27 cents or 30 cents? Oh, please answer this question. What is more, 27 cents or 30 cents? Everybody. 30 cents, right? And so by stacking them up, we can add those zeros. So now we can compare what comes after the decimal point. Looking at our place values, 0 wholes, 2/10 compared with 3/10. Okay, 0.27 is less than 0.3. When you stack these decimals up down below here, where you've got several of them to order from least to greatest, you can do the same thing. 0.884, 0.89, 0.879, and 0.0884. What do we add now? We're on PO7. Okay? What do we add now to make these all out to the same number of places? Zeros, right? We got to go out to 4 because our longest decimal has 4 places in it. And so now we are able to look at what comes after the decimal point. Which one of these is the smallest? Yeah. Yes. Which one of these is the smallest decimal? If we're looking at what comes after the decimal, I've got 8,840, 8,900, 8,790, and 884. Which one's the least? Right, that 0.0884. We can also look at the number of tenths and see it's got the least number of tenths. 8/10, 8/10, 8/10, 0/10. That's got to be the smallest. Okay? What would come next? Someone new. What would come next? Again, you can look at what comes after the decimal now because they're all the same number of places. Nice little math hack. Ryan?
0.879.
Yeah, 8790. Right? Because 8,790 is less than 8,840, which is less than 8,900. Also, look at our hundredths now, right? This decimal is done because we've used it. So the 3 that we had left, they all have the same number of tenths, 8, 8, and 8. But now to our hundredths. Now looking at our hundredths, 8, 9, and 7, 7 hundredths is less than 8 900ths. So that would come next. What comes third? What comes third?
0.8840.
Yeah, 0.8840. Again, looking at the number after the decimal point or looking at the number of hundredths. We got only 8 hundredths there. And then, of course, our greatest, 8,900, or the number of hundredths. It's got 9 of them. It's got the most. Okay. This is review from last year, yes? Do we remember this stacking method?
Yeah.
Talked about before, at least seen it before, okay? A very handy method to use here. Very handy method to use here. Fractions. The grand finale here. Says compare using less than, greater than, or equal to, show your work. No period at the end. My editor, goodbye. 3/6 and 5/10. What do you want to do? Is 3/6 less than, greater than, or equal to 5/10? And be prepared to defend your choice.
Wait, what?
We're on 5.
Oh, they're equal to.
Oh.
Wait. On 3/6 and 5/10?
Yes.
Yes, they're equal to.
Yes. How do you know that?
Because I know.
How?
I just know.
You just know? Oh, well, for the rest of us that don't just know, Maya? Okay, if you simplify each of these fractions, 3/6 simplifies to 1/2, 5/10 simplifies to 1/2. It's the same value, right? If you know that 3 is half of 6, 5 is half of 10, okay, you know that they are the same value. If you went with common denominators, which is another option, what's the common denominator of 6 and 10? This is where least common multiple comes into play, right? Because that least common denominator is just the least common multiple of 6 and 10. What is it? You just tested on this also. That LCM of 6 and 10. Anthony? 30, right? So if we can rewrite both of these fractions with the denominator of 30, it's going to help us compare them also. To get there, we have to multiply 6 by 5, which means we multiply 3 by 5. That gives us 15 thirtieths. To get to 30 from 10, we multiply by 3 and by 3, and that gives us 15 thirtieths as well. No matter how you slice it, no matter how you look at it, you make a circle graph, you make a pizza, you cut it into 6 pieces, shade it in 3, no matter how you do it, these fractions are going to be the same. Okay, so there's not one method you have to use every single time, right? You're going to get there either way. 3/8 and 7/12. Second time we've seen 7/12 today. But what can you tell me about these fractions? What symbol is going to go in between them? Zoe. Equal? And why do you say that? Nolan?
Less than.
Why less than?
Because 7/12 is greater than 3/8. Right? No, 3/8 is less than 7/12.
And how do you know that, Nolan?
Don't know.
Oh, you just know? Well, for those of us that don't know, that need an explanation, I need a defense. What do you want to be when you grow up, Nolan?
I don't know.
You want to be a lawyer? Doctor? Yeah. Think about if a lawyer went into the courtroom, said, "Judge, my client's innocent." How do you know? I just know. Looks innocent. Doesn't he? Yeah? Or you're like a doctor, person comes in, "Ooh, we have to amputate." "Doctor, why?" "I just know. No, I need a reason. Give me something to work with here." Anthony.
Alright, so my evidence is
Yeah.
you have to find the common denominator.
Sure. Okay, and what is the common denominator of 8 and 12?
24.
24. So Anthony's going back to some LCM here. And the LCM of 8 and 12 is 24. And what do we have to multiply 8 by to get there?
I multiply 3 by 3.
Good.
And I multiply 7. Shoot, I forgot.
Yeah, how do we get from 12 to 24?
2.
2, right? Multiply by 3 and by 3 to get 9 24ths. And multiply 7 and 12 each by 2 to get 14 24ths. Now you can see why 3/8 is less than 7/12 because we have the same denominator. 9 24ths is less than 14 24ths. Okay, that's one way to do it. Anyone have a second way?
3/8 is less than 1/2.
Very good. If we do what we did at the beginning of class, we can compare to 1/2. I know that 3/8 is less than 1/2 because half of 8 is 4. I only have 3. I know that 7/12 is greater than 1/2 because half of 12 is 6. I've got 7. So if I know that, on our number line, if I'm comparing them to 1/2, 3/8 is somewhere over here. Don't know exactly where, but somewhere over there. 7/12 is somewhere over here. Don't know exactly where, but somewhere. It's greater than 1/2. Then I know that 3/8 is less than 7/12. Okay? Yes, Nolan?
I actually know the next answer. I know how to do it.
Know how to find it?
Yes.
5/11ths and 14 33rds. Dr. Nolan, take us away.
Well, you have to find the common denominator.
Sure. Which is what?
So 33.
Okay.
But that already has 33, so you can just keep 14 over 33.
Isn't that nice? The spirit of Christmas.
And then 11 to get 33 is 3. No?
Yeah.
3 by 5 is 15, and 15 is greater than 14 over 33. So 5 over 11 is greater than 14/33.
Very good. Because 15, think of like a test score, right? 15 out of 33, still pretty terrible, but better than 14 out of 33. That was always my excuse to my parents when I bring home a bad test score. Well, at least I got something right. Or, if I got in trouble at school, you kicked a kid. At least I didn't kick 2 kids. It's always, it rarely worked, rarely got me out of trouble, but, so. So that is fractions, okay? Common denominators works great. Comparing to 1/2 or 0 or 1 whole works great as well. And so looking at the rest of these, this is for homework. You've got some, this one's as a mixed number. This is an improper fraction. Remember I said earlier, write your values to be the same thing. Convert 13/4 to a mixed number. Convert 2 3/4 to an improper fraction. That can help you. And then down at the bottom, kind of a review of everything here. We've got several fractions to order from least to greatest, several decimals, and then a mixture of the two. Ooh. So you might want to convert your decimals to fractions. You might want to convert your fractions to decimals, okay? But it might help if they're all in the same value. Questions, comments, concerns, complaints, compliments, congratulations, or criticisms for PO7? None at all. Homework tomorrow is the entire objective, okay? The integers that we have left, the decimals we have left, and the fractions we've got left. You need to be able to defend your answer, okay? If I come around and I don't see any work shown tomorrow, I'm going to ask you, why'd you put this? And if you don't know, might not, well, it's not a pip, no. I might not give you credit. Okay? Well, if you can defend it, then that's fine. That's what I want. I want your defense. I just know will not pass in the court of law. It will not pass in my room. This is my house, Penelope. Okay. Anything else? All right. That's my math.